Dear everybody, I welcome you for starting the second chapter of Geology. Chapter 2, Minerals. As we know that man lives in the outer surface of Earth's crust and contacts with its minerals. Man uses them for his daily life. Man cultivates crops in the Earth's soil, build houses from its materials, and extract minerals from its rocks. And if we look to the way we live, we will find that our life is so much related to what is on or near the Earth's surface. We will learn much by studying composition of the crust and using its constituents to protect ourselves from the natural disasters like earthquakes and volcanic eruptions. Long time ago, man used chert to make knives and spear. I mean Paleolithic man. To kill animals and to feed on them. Also to defend himself. He used colorful minerals like yellow and red, as in hematite and limonite, to color the walls of the caves. After knowing fire, he used clay to make hard ceramic. I mean pots. Ancient Egyptians. We know that the Egyptians built great civilization through the last 5,000 years. Ancient Egyptians have also used colored minerals and stone for ornamentation, like amethyst, malachite, emerald, and turquoise. And nowadays, minerals are used in many industries. For example, calcite used in cement industry, quartz in glass industry, magnetite and hematite in steel industry. And we use them to build cars, railways. Also, we use feldspar to make ceramic. And we extract metals such as copper and gold from the ores and shape them into different objects. Crust is composed of three types of rocks: igneous, sedimentary, and metamorphic. By definition, a rock is an aggregate or composed of one or more minerals. Some rocks are made of one mineral, I mean single mineral. An example is limestone. Limestone composed of the mineral calcite, calcium carbonate. So, in general, a rock consists of a group of minerals that have some common properties. For example, the minerals of an igneous rock have crystallized from the magma at small range of temperature and pressure. Granite, composed of quartz, feldspar, mica, and they all have common properties. Also, minerals of sedimentary rock, transported and deposited by a river within a limited range of grain size and its specific gravity. The best example is the cultivated land of the Nile Valley, formed of silt and clay, representing the floodplain deposits of the Nile. So, a mineral is a basic natural unit from which a rock is formed. So, what is a mineral? The mineral is solid, inorganic, naturally occurring substance having definite chemical composition and crystalline form and distinct crystalline form. So, coal and oil are not minerals because coal is organic origin and doesn't have or doesn't have special crystal form. Also, oil, the same way, is organic origin and liquid. And now we will take a look at the minerals as all other natural constituents of Earth are formed of elements which are known to us. Some minerals are formed of one element, like gold, sulfur, graphite, copper, and also diamonds are formed of one mineral. However, the majority of minerals are formed of two or more elements, which unite to form a stable compound according to chemical bonds laws. Quartz, as example, consists of silicon dioxide and calcite consists of calcium carbonate. We identified elements, or man identified elements as more than 100. but we found a limited number of them. Only 8 elements from more than 98.5% by weight of the rocks of the crust. These 8 elements are arranged in descending order as follows. Oxygen is 46.6, silicon is 27.7, aluminum is 8.1, iron is 5, calcium 3.6, sodium 2.8, potassium 2.6, magnesium 2.1, and the rest of elements is 1.5%. So, elements including most forming materials of economic value like copper, gold, carbon, lead, tin, and platinum share in the formation of only 1.5% of the rocks of Earth's crust. Mineralogists, or the scientists of minerals, defined more than 2,000 minerals, most of them found in little amount in nature. If we count common minerals and which have economic value, we will find they do not exceed 200 of minerals, while the mineral which form the rocks of its crust don't exceed tens and divide to few mineral groups. The most famous groups are as follows. Number one, silicates. Silicates like quartz, orthoclase, plagioclase, mica, amphipore, pyroxene, olivine. The second group is carbonates. For example, calcite, dolomite. The third group is oxides, hematite, magnetite, then sulfides, pyrite, galena, sphalerite, sulfates, gypsum, anhydrite, pyrite, and finally the native elements minerals like gold, copper, graphite, sulfur, diamond. So the most famous mineral group is silicates, then carbonates, oxides, sulfides, sulfates, and finally native elements minerals. As we know from the definition of the mineral, that it's supposed to have or it must have definite chemical composition and fixed atomic structure. According to the mineral chemical structure, few minerals have fixed and definite chemical compositions. For example, quartz made of silicon dioxide, while the majority of minerals have a composition that changes due to the replacement of one element by another, but is usually in small limits that doesn't exceed the atomic structure of the mineral. So we find that the main item in mineral definition is its crystalline or crystallized substance. The crystal form controls the shape of mineral and their physical properties as color, hardness, cleavage, and fracture, but also in its chemical properties. Crystal structure of mineral. The mineral forms or the mineral is forming from arrangement of atoms within a mineral in orderly arrangement, creating what is known as crystal form. The crystal is solid, geometrical body, has outer plane surfaces known as crystal faces. If we look at the building or the structural building of halite, the crystal form of halite is sodium chloride, known as rock salt, which is consists of combination between positive sodium ions with negative chlorine ions in a repeated sequence, produces characterized crystal for halite in form of cubic shape, equant. So halite forming cubic crystal from sodium positive ion and chlorine negative ion. And this shape known as equant mean cubic shape. And now, what are the main elements when we study minerals? If we look at the picture here, we will find that the crystal axis is the line passing by crystal center. This is crystal axis here. Okay? So this is crystal axis. Same way, and this is another crystal axis. Okay? It is a line passing by crystal center, and the crystal rotates around it, then faces, edges or angles of crystal may be repeated 2 or 3 times. They are taking the symbol A, okay, A, B, and C. But if they have the same length, we give it the names or the symbols A1, A2, and A3. These are the crystal axes. Okay. Number 2 of the main elements are angles between axes. Okay? Angles between axes are symbolized by alpha, beta, and gamma. Okay? Alpha, beta, and gamma. The crystal's symmetrical degree depends on the length of axes and the angles between them. So, when I want to classify the crystal systems, I have to consider the length of the axis and the angle between axes. Number three of the main elements when we are studying minerals is the crystal plane or the crystal symmetrical plane. Uh, the crystal symmetrical plane divides the crystal into two identical halves according to the previous mineral crystals may be divided into 7 crystal systems. But here, the crystal symmetrical plane divides, okay, divide the crystal into half, okay, into half with the same identical shape, okay? And now, according to the elements, we can divide the mineral crystals into 7 crystal systems. Into 7 crystal systems. So we are going to consider A, B, C indicates the lengths of axes, while alpha, beta, and gamma indicate the angles between axes. The first system is the cubic system. If we look at the cubic system, okay, here, the cubic system, as we see here, the crystal has 3 axes which are equal in length and has perpendicular angles. The system is characterized by the greatest number of crystalline symmetrical systems. In this system, I mean the cubic system, A1 equal A2 equals A3, the same way alpha equals beta equals gamma. Equals gamma. If you look here, like this, you will find axis here. These 3 axes, A1, A2, A3, are equal. Okay? And the angles between them are equal. This is alpha 90, beta 90, gamma 90. Gamma 90. So the cubic system consists of three axes. A1 equal A2 equal A3, and alpha equals beta equals gamma. Number two, tetragonal system. Tetragonal system has three axes. The two horizontal axes are equal, E1 equal E2, but they are different in length from C axis. So the crystal has three perpendicular axes. Two of them are equal in length, and the third is different. So A1 equals A2 doesn't equal C, and alpha equals beta equals gamma. This is the tetragonal system. Orthorhombic system. Orthorhombic system has three axes, but are different in length. A doesn't equal B, doesn't equal C. But all these axes are perpendicular to each other. So alpha equals beta equals gamma. This system is orthorhombic system. The crystal system number 4 is monoclinic system. Here, monoclinic system is like orthorhombic, but one angle doesn't equal 90 degrees. So the axes are different in length. A doesn't equal B, doesn't equal C. And the angles, two of them are equal, alpha equals beta and doesn't equal gamma. This system is monoclinic. System number 5 is triclinic system. Triclinic system, all axes are different in length, and it has three axes as we said, and all angles between these axes are different. I mean, A doesn't equal B, doesn't equal C, and alpha doesn't equal beta, doesn't equal gamma. So this crystal system has three axes. All are different, especially axes are different in length. A doesn't equal B, doesn't equal C. And the angles between these axes also are different. Alpha doesn't equal beta, doesn't equal gamma. The crystal system number 6 is hexagonal system. Now, the number of axes are different. All the previous 5 crystal systems have 3 axes, but now the hexagonal system has 4 axes, 3 horizontal axes which are equal in length, but one vertical axis is different than them in length. So the crystal system, the hexagonal system here has 3 horizontal axes which are equal in length, intersect each other by equal angles. They are perpendicular to the fourth axis. So the fourth axis is perpendicular to the other 3 horizontal axes. The fourth vertical axis is hexametrical with the presence of horizontal symmetrical plane. So the hexagonal system has horizontal symmetrical plane. So it has one horizontal symmetrical plane. And as I said, A1 equal A2 equal A3 doesn't equal C. And C is vertical axis on the three horizontal axes. Number 7, trigonal system. What is trigonal system? The crystal has three horizontal axes, like hexagonal, which are equal in length, intersect each other by equal angles. They are perpendicular to the fourth axis, which differs in length. The fourth vertical axis is trimetric with no horizontal symmetrical plane. So, trigonal doesn't have any symmetrical plane. So, it doesn't have horizontal symmetrical plane. And we should remember that A1 equal A2 equal A3 doesn't equal C. All systems have three axes except the hexagonal and trigonal have four axes. Now we have finished this session. I wish you all the best with Mr. Samet. Thank you so much.